You're listening to the N2K Space Network.
Hey everybody, Dave here. Have you ever wondered where your personal information is lurking online? Like many of you, I was concerned about my data being sold by data brokers. So I decided to try Delete Me. I have to say, Delete Me is a game changer. Within days of signing up, they started removing my personal information from hundreds of data brokers. I finally have peace of mind knowing my data privacy is protected. Delete Me's team does all the work for you with detailed reports, so you know exactly what's been done. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners. Today, get 20% off your Delete Me plan when you go to joindeleteme.com/N2K and use promo code N2K at checkout. The only way to get 20% off is to go to joindeleteme.com/N2K and enter code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
Today is February 10th, 2025. I'm Maria Varmazes, and this is T-Minus.
T-Minus. 20 seconds to LOS egress. Go for deploy. Roger, roll. Live.
SpaceX and VAST are looking for science and research ideas that'll enable life in space and on other planets.
4.
Spider Oak has been selected by the U.S. Air Force Research Laboratory to enhance the Space Force's ability to integrate commercial satellite networks during emergencies seamlessly.
3.
ICEYE and SATIM are partnering on a new product that combines AI and SAR to detect and classify vessels, aircraft, and land vehicles from space.
2.
Rocket Lab launched its 59th Electron mission, deploying 5 satellites to low Earth orbit for French Internet of Things constellation operator Kinéis.
1.
MDA Space has been selected by Globalstar as the prime contractor for a next-generation low Earth orbit constellation. And our guest today is Mark Russell, CEO of General Hypersonics. They're working on a new launch system capable of sending small satellites, cargo, and other payloads around Earth or to orbit from land or sea. It's a great chat, so stick around after the headlines. Happy Monday, everybody. MDA Space has signed a contract with Globalstar to be the prime contractor for the satellite operator's next-generation low Earth orbit constellation, with a total contract value of approximately 1.1 billion Canadian dollars. As part of the definitive contract for the full LEO constellation, MDA Space will manufacture more than 50 MDA Aurora software-defined digital satellites for Globalstar. MDA says this contract is a follow-on to an initial authorization to proceed contract with an undisclosed customer previously announced in November 2023. Mike Greenlee, the CEO of MDA Space, said in the press release, "With the full contract now in place, we are moving full speed ahead on the program." No further details on when the constellation is expected to be delivered or launched were shared in the announcement. Rocket Lab's IoT for You and Me mission lifted off from New Zealand over the weekend, successfully deploying 5 satellites for French Internet of Things constellation operator Kinéis. The mission was Rocket Lab's first Electron launch of 2025, the 4th launch for Kinéis to date, and the 59th Electron launch overall. Rocket Lab has one more dedicated launch for Kinéis scheduled and will then have deployed their entire constellation in less than 1 year, which is pretty impressive. The Kinéis constellation is designed to make it possible to connect and locate any connected object anywhere in the world, which enables data transmission to users in near real time. The Kinéis constellation is aiming to support forest fire detection, water resource management, infrastructure and energy network monitoring, transport and logistics tracking, and much more. Rocket Lab says the launch date for the 5th Kinéis launch of this series of missions will be announced in the coming weeks. ICEYE and SATIM are partnering on a new product that combines AI and synthetic aperture radar, or SAR, satellite operations to detect and classify vessels, aircraft, and land vehicles from space. The companies will combine ICEYE's satellite imagery with SATIM's AI-powered imagery analytics solutions into new products. After an initial pilot phase, the partners plan to release a series of generally available products later this year. Spider Oak has been selected by the U.S. Air Force Research Laboratory to enhance the Space Force's ability to integrate commercial satellite networks during emergencies seamlessly. The funding for the program is supported by a tactical funding increase contract and aims to develop a secure, automated control plane for the Commercial Augmentation Space Reserve Program, also known as CASER. The CASER program is managed by Space Systems Command's Commercial Space Office, and the program seeks to ensure that the Space Force has immediate access to commercial satellite capabilities during peacetime and crises, enabling a flexible surge capacity to meet increased mission demands when needed. Spider Oak's technology will aim to address a critical need, which is automating and securing the activation and coordination of commercial assets in real time, ensuring seamless collaboration between government and commercial partners. For the first demonstration, Spider Oak is partnered with Planet Labs and Space Systems Command to create a robust proof of concept. The project's success could have far-reaching implications, enabling broader adoption of similar frameworks across government and commercial entities. And SpaceX and VAST are looking for exceptional science and research ideas that will enable life in space and on other planets. Approved projects will be able to leverage the Haven 1 Space Station Lab, Dragon spacecraft, and/or private astronaut missions to the International Space Station. The companies say submitted research proposals will be reviewed and evaluated based on their scientific and technical merit, feasibility, and alignment with mission objectives. And if you are interested, we've added a link in our show notes for more details. And speaking of those show notes, our producer Alice Cruz has more details to share.
Yes, I do. Thanks, Maria. You can always find links to further reading on all the stories Maria mentions in the show in the selected reading section of our show notes and at space.n2k.com. You just need to click on this episode title. We also include extra stories that don't make the headlines. Today we have an announcement from Aegis Aerospace and Texas A&M, who are collaborating on a new flight facility on the ISS, and another on a new appointment at Rivada.
Thank you for that, Alice. Hi, T-Minus crew. If you would like daily updates from us directly in your LinkedIn feed, be sure to follow the official N2K T-Minus page over on LinkedIn. And if you're more interested in the lighter side of what we do here, we are at T-Minus Daily on Instagram, and that is where we post videos and pictures from events, excursions, and even some behind-the-scenes treats for you. And links are in the show notes. Hope you will join us there.
Cyber threats are evolving every second, and staying ahead is more than just a challenge, it's a necessity. That's why we're thrilled to partner with ThreatLocker, the cybersecurity solution trusted by businesses worldwide. ThreatLocker is a full suite of solutions designed to give you total control, stopping unauthorized applications, securing sensitive data, and ensuring your organization runs smoothly and securely. Visit threatlocker.com today to see how a default deny approach can keep your company safe and compliant.
And we're bringing you more of our chats from SpaceCom 2025 this week. And today we have Mark Russell, and he's the CEO at General Hypersonics. And Mark's working on a new launch system, and I asked him where the idea for his pipeline to space came from.
After working for Blue Origin, I had this idea, actually even before working for Blue Origin, that you could launch what we call impulsively, meaning you don't have to carry all the fuel. The rocket has to, create a velocity, which then puts you into orbit. You could carry a lot less if you exited or left Earth with velocity. So not a gun. This thing is called a ram accelerator, and it's a tubular structure that fits underground. It looks like drill pipe.
Yep.
And it is a ramjet in the ground. And the sidewalls of this steel tube and the sharp-nosed projectile flies through compressed air and natural gas. In doing so, it sets up a shock wave, and it rides through this wave in the tube like a surfer riding a wave in the ocean. And it exits at velocities that are helpful in getting you off the planet. And then you put a small engine into your second stage, and that gets you into orbit.
That's it's the idea makes a lot of sense when you describe it. It's like it feels very intuitive, and my brain goes, "Why have we never tried something like this before? This is so cool."
Because it's rocket science.
Yeah, because it's literally rocket science. It's really hard. That's why.
Yeah, no, there's a group out of the University of Washington in Seattle, and I went and visited when I was 19. They had this tubular thing. It was all steel and a bunch of sharp projectiles. Looked nothing like aerospace. Yeah. Who knew that 20-some years later I'd come back and I funded the lab?
Yeah, stayed in there. Yeah. You just percolated for a bit.
So a ram jet is the simplest jet engine. You don't need any moving parts except, in our case, the projectile.
Yeah.
And that's what's different about it. It makes it super easy to leave all that energy on the ground. You travel through it, and this fairing then comes out at high speed and then releases a payload into the upper atmosphere, which then turns on a second stage engine, and we go. But yeah, it's taken years for us to master the technology.
I can imagine. Yep.
And after leaving Blue Origin, I started actually drilling deep holes for mining exploration. My whole family, third generation miner. So I went back to the family business to figure out all these things I needed to learn in order to start what's now Rig Launch.
You had to dig down to go way up.
You had to go down to go up. That's right.
That's
it's
poetic,
a visionary
honestly.
thought.
It's really poetic.
It was a big leap for me, honestly.
I love that. So you were showing me some really cool videos of like the development work that you all have been doing. Tell me a bit about what you've been doing to actually to bring this to bear.
Sure. So we started small. We actually built. The very smallest version of this was 1/2 inch in diameter, and we called it tabletop ram accelerator. So when working for Jeff Bezos, we always had these thought experiments. What could you do kind of simply? And that was the next thing after your thought experiments. How could you prove it? And so the University of Washington, we got them under contract. They taught us how it would work, and then we started making our own systems. And we went from very small, and then we grew it to something that was about 4 inches in diameter, and then grew it up, and we got a NASA contract, a small one, to do some research. And we went down to Spaceport America with a water well rig, and something is about 20 inches in diameter and about 9 feet tall. And that was our first kind of impulsive test out of the ground.
Yeah.
And then we've gone back and refined that. There's some really new breakthrough that we had at both the university and in our labs that allowed us to do something pretty amazing with the tech. It simplified everything. I can't tell you all about it.
Can you tell me anything about that?
Well, I can't
even
tell
a sprinkle of it?
That heavier projectiles, meaning the ones that need to carry things into space, are now very possible with this tech.
Wow.
Early on, they tested very light projectiles and had a lot of parts to it. We simplified it all, and now we're testing horizontally every single day in Washington State, running these systems horizontally.
Yeah.
And this year, we're looking to take that now into the ground again and launch all the way to the Kármán line.
Wow.
And do it again and again and again. Set a world's record. That's actually what we're trying to do this year. It's pretty simple to start with. I mean, in the future, it'll be larger systems that carry those bigger pipes. So right now, a simple water well rig. You literally just show up, drill a small, short hole, and now you have this distance. And it's a couple 100 feet long.
Yep.
And you can carry, small projectiles, but they would reach the Kármán line on impulsive flight alone. So
what would be the I'm gonna say the reload time? Like how quickly could you think in theory this could go pretty quickly, like one after the other? Or?
So we can launch with our system horizontally every 90 seconds. It is a radical different cost and timing for what we call hypersonic flight. Now, I'll tell you a little bit about what hypersonics really means.
Please, yeah.
So when I formed this, we actually have two companies. One company is called Hypersciences, and the other company is called Pipeline to Space, which I thought was pretty simple. It's a pipeline that takes you to space. But Hypersciences was all about developing the core technology with the University of Washington in our own labs. Hypersciences got funded by Shell and Exxon and some very large mining companies because we found that you could kinetically impact rock, drill for geothermal energy very quickly, as well as tunnel bore quickly. So we got very good at this at a scale about the size of a banana, if you will. We were launching things that were iron and concrete into rock at Mach 4. And that means that you could carry all that energy, break the rock really efficiently.
Wow.
DARPA tested this in the 1970s with a howitzer. And we found that if we could get funded to build something that was good for Earth first, it would actually teach us everything we needed to know. And it worked. We actually are under contract. We tunnel bore, we drill. And then Pipeline to Space and Hyperscience got together and created General Hypersonics, which does rig launch. That's how these two companies have come together. Hypersonics.
Please,
we should probably chat a little bit about what that means.
Yeah, because it's something that very hot word in our world, and I wanted to hear you kind of walk me through that one, if you don't mind.
Yeah, it's now becoming sort of an everyday household term. The U.S. is getting behind in hypersonics, and generally. Supersonic means you're going, one or more times the speed of sound. Right. So if you're in a jet aircraft and you're flying along around 30,000 feet, you're very close to Mach 1. You're at about Mach 0.98 or so. Any faster, drag rises, and then you get a sonic boom below you and around you. However, when you go above the speed of sound substantially, the drag actually drops. You actually have a much easier time getting through. But getting through that barrier, the old sound barrier.
Yep.
Well, hypersonic means you're going 5 times the speed of sound.
Yep.
So in meters per second, speed of sound is 343 meters per second. So at Mach 5, we're doing 1,750 meters per second. It's fast. It's like, thousands of miles per hour. And when you go that fast, a lot of amazing things happen. In the industrial side, when you impact things, everything looks like a liquid for a moment. It goes hydroelastic, and that's why you get such efficient rock breaking. And because we started testing this in my grandfather's old mine tunnel, we wanted to be super safe, but we also found out, holy cow, this is like Velcro and Tang. For NASA, we finally found something. We just pay the bills while we learned. So that was kind of a fun way to do it. So hypersonic is bringing all that energy with you. So what rig launch does is it has a much bigger, system, half meter, meter, and larger, and encapsulate your satellite, and you put it in a tube, and you bring it out at these high velocities. Then you don't have to have this big rocket engine. So we get rid of that big first stage booster, and that velocity carries you right to the edge of space, and then you put that rocket engine on.
Does it allow larger payloads for the rocket? Is that what you're sort of imagining long term?
You get large. I would say large. I think heavy lift is still going to be the domain of the SpaceXs and the Blue Origins and the NASAs for a while. But we're talking about being able to put up significant payloads every few minutes. So the aggregate number of kilograms to orbit could actually be quite large with ours. In fact, larger than the heavy lift over time. So think about this. If you wanted to ship a next day envelope, you put it on FedEx or a carrier, DHL. You don't put it on a cargo ship. And that's really the problem with big rockets today is it takes months to years of integration and a lot of complex engineering to get that thing, even if you're riding as a ride share. Yeah. So all the small satellites are just waiting. There is literally a line out the door.
There sure is.
For responsive space. Yep. And that's what we bring to the equation is not just one rig. we're looking at these waterborne platforms, drill rig platforms, and we have them everywhere around the planet. You can hit any orbit, anytime. So it's a fulfillment center.
That makes a lot of sense.
That is what we're looking for. Fulfillment centers everywhere to reach orbit.
We'll be right back.
And now, a message from our sponsor, Zscaler, the leader in cloud security. Enterprises have spent billions of dollars on firewalls and VPNs, yet breaches continue to rise by an 18% year-over-year increase in ransomware attacks and a $75 million record payout in 2024. These traditional security tools expand your attack surface with public-facing IPs that are exploited by bad actors more easily than ever with AI tools. It's time to rethink your security. Zscaler Zero Trust plus AI stops attackers by hiding your attack surface, making apps and IPs invisible, eliminating lateral movement, connecting users only to specific apps, not the entire network, continuously verifying every request based on identity and context, simplifying security management with AI-powered automation, and detecting threats using AI to analyze over 500 billion daily transactions. Hackers can't attack what they can't see. Protect your organization with Zscaler Zero Trust and AI. Learn more at zscaler.com/security.
Welcome back. Since Valentine's Day last year, ESA's Euclid telescope has been on a mission, a little love letter to the cosmos, if you will. It's been working on creating a 3D map of the known universe as it investigates what parts gravity and dark energy and dark matter have all played in the formation of the aforementioned universe, NBD. Gravitational lensing is one of the many phenomena that Euclid is keeping an eye out for, and that is when light from a distant galaxy gets all squashed and stretched by the supermassive gravity of a galaxy that is closer to us. It makes those smear-like light streaks that you might remember from Hubble or Webb images, and those gravitational lenses also allow us to see extremely distant objects that we wouldn't normally be able to see. That distortion of space-time is like a handy shortcut for us. And when the lens hits your eye like a big pizza pie, that's an Einstein ring. Sorry, Dean Martin. If you happen to look at the right galaxy at the right alignment, and it happens to be lensing something else, you may just see what looks like a halo instead of a smear or a swoop of a gravitationally lensed distant galaxy. And that ring is called an Einstein ring. It's both very rare and very scientifically useful. And Euclid has spotted such a ring by looking at galaxy NGC 6505, which is a mere 590 million light years from us, practically next door. But the galaxy that, to our view, is forming the ring around NGC 6505 is both unnamed and unknown, and it is 4.42 billion light years away. Exciting and beautiful, the best combination. And that's it for February 10th, 2025, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like the show, please share a rating and review in your podcast app. Also, please fill out the survey in the show notes or send an email to space@n2k.com. We're privileged that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K makes it easy for companies to optimize your biggest investment, your people. We make you smarter about your teams while making your teams smarter. Learn how at n2k.com. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.